Year 6, Mrs. Green, here with your Wednesday maths lesson. Before I start all that, I just want to say how I have been blown away by the amount of children who've been engaging with our online lessons and actually sending the work in too. Every time we hear the email ping, it really makes us happy. So keep up the good work, Year 6. However, there are a few children that need a special mention. Here we have our top 10 Year 6 children for the fastest speed on TT Rockstars in Year 6. And it's really lovely to see some new names up there as well. So well done, Amelia, Kyra, Logan, Peter, Erin, Charlie, Billy, Samson, Harrison and Blossom. As well as that, I am choosing to showcase Alexi's work today. I like that she has timed herself, as that will allow her to improve on her speed, and I also like that she's used a range of written methods and mental strategies depending on the type of question. Well done, Alexi. All of these children mentioned today will receive one class dojo. Okay, let's get straight into it then. So I've chosen today for our starter task long multiplication, because I know this is something that many of us still struggle with, and the more we practice something, the better we become. So have a look at a straightforward long multiplication problem to begin with, and then we've got a reasoning problem that also involves long multiplication as well. So pause the video now and have a go. Okay, let's check, and I'm going to model how we would solve this. So the first thing we need to consider is how to set out our problem. Okay, so I've put the largest number first and the smallest number underneath, set out into their correct columns. With long multiplication, it doesn't matter so much in the order that you do. And I have remembered the most important thing, my smiley face, my placeholder, because I'm going to be moving from the ones column to the tens column. And now I'm going to start to multiply. First of all, I'm going to do 3 times 4 and then 3 times 6. And then I'm going to move over and do 4 times 4 and then 4 times 6. And finally, I'm going to add my answers together, giving me an answer of 2,752. Okay guys, and time for you to check this next problem. Right, today we're going to be moving on and learning how to multiply fractions by integers. And some of you might be wondering what that actually means. Well, an integer is actually a whole number. And some of the key vocabulary that we're going to need for this lesson is multiply. Another way of saying multiply is the product. Another way of understanding multiply is lots of. We're going to be thinking a lot about multiplying by whole numbers as well as fractions, and still considering the numerator and the denominator. Okay, I want you, before we start, to have a go. How would you go about solving this problem? So pause the video now. Some of you might have had a good go. Some of you might have tried to draw a diagram to help you understand it. And some of you might be like, no, I haven't got a clue, and that's fine. We're going to talk about it now. So the way to look at it is to look at a shape with 3 quarters. So look very carefully. We've got a circle with 3 quarters shaded, but the question is asking us for 4 lots of those 3 quarters. So there's 1 3/4, there's 2 3/4, there's 3 3/4, and finally 4 3/4. So what would the answer be? Well, in this case, we can just count the shaded parts. So 3 times 4 is 12. So our answer in this case was 12/4, but we all know that we can't give our answer as an improper fraction, so we need to convert it back to a mixed number fraction. So 3/4 times by 4 actually gives us 3 whole ones. Okay, my turn again to model. So as you can see, this shape is demonstrating 3/7, but there is only 1 lot of 3/7. So I need more. So there's 2 lots of 3/7, 3 lots of 3/7, and finally 4 lots of 3/7. So we can understand 3/7 times 4 as 4 lots of 3/7. And let's count the shaded part. So we've got 12 over 7. And once again, we cannot have an improper fraction as an answer, so we would convert it back to a mixed number fraction, giving us 1 5/7. But what do you notice? Okay, let's investigate a bit further. So I'm going to write down some examples. So let's have a quarter multiplied by 2. And I'm going to write the answer down. Look very carefully what the answer is. See if you notice any pattern. Let's have a go at writing another one. Let's make it a bit bigger. So 2/3 times by 5. Let's write the answer down now. Okay. Do we notice anything now? Right, I'm going to get my highlighter pen now. Look very carefully what I'm going to highlight. Let's see if we notice anything. And down here as well. Okay, look very carefully. What do we see there? So we're looking at the numerator multiplied by the integer. Gives us the answer for the numerator for the answer. Let's have a look here then. Okay, so I've got the numerator from my question times by the whole number gives me the answer, the numerator answer. So 2 times 5 is 10. Is that revealing our steps to success? Okay, let's have a look when we have to multiply a mixed number fraction by an integer. So what I would do first of all, I would multiply the whole numbers first. So in this case, we have 3 times 3 equals 9 whole numbers. Then I would multiply the fraction by the integer. So a half times 3, if we're going by our method from previous, we would multiply the 1 by the 3, that would give us 3, and the denominator stays the same, but because we have an improper fraction, we would convert it to a mixed number fraction. Then adding both the answers together would give us 10 1/2. Okay, here we have some problem solving. So how would I go about approaching a question like this? Well, straight away, I would be able to guess this answer without even solving it, because I would look at the whole numbers. So 6 times 2 would give me an answer of 12. So my answer is going to be around 12. But the next one, 3 times 7 is 21, will give me an answer of at least 21. So straight away, I would probably agree that this answer is true, that the second calculation is bigger than the first one. Now I'm going to have a go at solving it. So looking at the first one, 6 times 2 is 12. Then I would do 6 times 9/10, which would give me 54/10, but I have to convert the improper fraction back to 5 4/10 and simplify that to 5 2/5, and then I would add all the answers together, which would give me a total of 17 2/5. Now let's have a look at the second part. And the calculation for the second part, so the whole numbers multiplied, 3 times 7 is 21, then multiply the fraction by the integer, 2/9 times 7, which would give me 14/9, which I would then convert to 1 5/9, and then I would add my answers together. 21 add 1 5/9 equals 22 5/9, making this calculation true. Okay, another problem to solve. There are 5 children at a party. Each child needs 1 pie plus an extra 3/10 of another pie. How many pies need to be ordered? Prove it. Well, first of all, we need to work out what our calculation would be. Okay, let's have a go at solving this. So first of all, we're going to multiply the whole numbers. So we're going to multiply 5 times by 1, which is 5. And then we're going to multiply the integer again, but this time by the fraction. And we know from looking before, we multiply the integer by the numerator, which is 15, and the denominator always stays the same. And as you can see, we've once again got an improper fraction, so we need to convert it to a mixed number fraction. I hope you guys are awake because you might be able to notice that that could be simplified. What could it be simplified to? Okay, 1.5. And then finally, we need to add it all together. So 5 add 1.5 will equal 6.5. Calculation gives us the answer 6.5. But does that answer the question? Let's go back to the question. How many pies need to be ordered? Well, to make sure, to guarantee that 5 children all get 1 3/10, which we know equals 6.5, we would have to order 7 pies. Right, let's have a look at another reasoning problem. So, Trevor created an image to represent his calculation. 256 times by 5 equals 14 1/6. Find and correct Trevor's mistake. Well, the first thing we need to ask ourselves, do we need to check the calculation? Well, first of all, look very carefully at the problem because you might notice something without even needing to calculate it and check it. So I'm going to look at his image. So I can see here we've got 1 whole 1, 2 whole 1s, and 5 6. So in that row, there's 2 and 5 6. So I've got 1 lot of 2 and 5 6, 2 lots of 2 and 5 6, 3 lots of 2 and 5 6, and 4 lots of 2 and 5 6. Well, hold on a second. The question says 256 times 5, so it's asking us for 5 lots. So what's missing is the 5th lot of 2 and 5 6. So Trevor would have needed to draw an extra row to make his calculation correct in his representation. Okay, our turn at another reasoning problem. Francis is practicing for a school concert. I need to practice for more than 15 hours. I can practice for 3 4/7 hours a week. What is the minimum number of weeks Francis should practice for? And explain your answer. So pause the video now and have a go, and then we'll have a go at answering it all together at the end. Okay, well, to approach this problem, I would straight away be thinking about my times tables. I'll be using some multiplication facts to help me answer this. So we need for Francis to practice for more than 15 hours. So I'm just going to look at my whole number, my 3. She's going to practice for 3 4/7 a week. So 3 times 4 gives us 12. So if she was to practice for 4 weeks, she'd be practicing for just over 12 hours. Let's have a go at calculating that to see. So if she was to practice 3 4/7 hours for 4 weeks, she would be practicing for 14 2/7. Therefore, that would not be enough for her to be practicing more than 15 hours. So again, using our times tables, let's have a look at practicing for 5 hours. Straight away, we know that 3 times 5 is 15, so she would definitely be practicing for more than 15 hours. Let's have a look. So if she was to practice for 5 weeks, we would do 3 times 5 is 15, then the fraction, multiplying the numerator by the integer, 4 times 5 is 20/7, which would give us 2 6/7 when converted. Let's add them together, so she would be practicing for 17 6/7 hours, which is more than 15 hours. We couldn't use 4 weeks as she would be practicing for less hours. So to answer the question, she would need to practice for 5 weeks. Right, on to your turn now. Here are your chili challenges. Pause the video at the chili you want to try today. If you find that you have got on really well with the chili, why don't you challenge yourself and have a go at moving on to the next chili as well. Okay, On the next few slides, you will also see the answer, so you'll be able to check your work. Pause the video when you get to your chili. And as always, Year 6, keep sending your work into the Year 6 email. And enjoy the rest of your day. I'll be back tomorrow with more maths.